On the 10th day of math, Miss of Math gave to me a product integral. That's right, for day 10 of Mathmas, we're gonna go ahead and integral that combines an infinite product. This was an integral that's straight up of a math integration bee, and I actually found it on Maths 505 YouTube channel, and it was actually really exciting how he solved it, so I'm gonna show you just the way he did it. The solution is beautiful. It's going to require a very easy trig identity, some L'Hopital's rule, and then some basic integration at the end. Let's go ahead and do it. We have the integral from 0 to pi over 4 of x, and then we have the infinite product from k is equal to 1 to infinity of cosine of x over 2 to the power of k, and obviously with some disrespect to x. And the way you need to solve this is first dealing with this infinite product, because if you can't solve that, then this integral just won't be able to have a solution. So let's go ahead and talk about what the infinite product actually is. So just like a summation, you're multiplying all these different products starting from k is equal to 1 to infinity. That's basically how an infinite product works. So let's just say, for example, I have a finite product. So I'm gonna start from k is equal to 1 to some value n of cosine of x over 2k. And let's just go ahead and write this stuff down. We'll start off with k is equal to 1, so we'll have cosine of x over 2, not too bad. And then we'll now start with k is equal to 2, so cosine of x over 2 squared, in other words 4. But instead of adding, we're multiplying. That's what the infinite product does. And if we continue that process, we're gonna have cosine of x over 8, and it's just gonna continue all the way till we get to the very end, which is gonna be x over 2 to the power of n. And the reason why I'm rewriting this is because in Maths 505 channel, he thought about possibly this can cancel out using a basic trig identity, and that is the double angle formula. So let's think about sine of 2x, which in fact, if you guys want a geometric proof of that, we should definitely do a video on that because that's actually pretty exciting. But the sine of 2x is gonna be 2 sine x cosine x, which gives us the cosine that we need. So if we divide the 2 sine to the other side, we'll have sine of 2x over 2 sine x, and that's gonna equal to the cosine x. So whatever this term is, then this is gonna equal to sine of twice that value over 2 times sine of the particular value. And that's what we're gonna need over here. So let's just say, for example, that we have the infinite product from, or not the infinite product, we'll actually do the finite product of this particular term. Well, now we're gonna go ahead and change this because now we have cosine of x over 2. This is our input value. So this will equal to sine of 2 times that. In other words, sine of x over 2 times sine of the particular input value that we originally had, and that's gonna be sine of x over 2. We continue this process with this one, and this will be sine of 2 times x over 4, in other words, x over 2, over 2 sine of x over 4. And I'm gonna continue that process again, and that's gonna be sine of x over 4 over 2 sine of x over 8. And now if we continue all those terms, then we're gonna be left with this one. So that's gonna give us a sine of x over, or I'm gonna actually leave it as, because we're multiplying this by 2. So maybe there's gonna be 1 left over. So x over 2 to the n minus 1 over, and then we're gonna have, oh my gosh, I cannot believe I'm losing this one. And that's gonna be 2 sine of x over 2 to the n. There we go. That's gonna make a lot of sense. Okay, now look at the pattern here. Notice that we have a sine x over 2 cancels out with this one. Sine x over 4 cancels out with this one. And then you're gonna have a sine x over 8. It's gonna cancel out with the sine of x over 8. So the bottom and the top cancels out, on and on and on. This will cancel out, leaving us with this right here. So now we can go ahead and say that this entire infinite product is gonna equal to sine, because that's what's left over, over, but then we have multiples of 2. So 2 times 2 times 2 n times. So we have 2 to the n, and now we're gonna have sine of x over 2 to the n. And for this particular case, for the purpose of what I'm gonna do, I'm gonna rewrite this as x 2 to the negative n. You're gonna see why I'm doing that in a second. Okay, well, we are concerned with what this happens when n approaches infinity. That's what we care about. So we're gonna go ahead and take the limit as n approaches infinity of the infinite product. So we have k is equal to 1 to n of cosine of x over 2 to the k. And what we're doing is taking the limit as n approaches infinity of this right here. Now remember, we're taking the limit as n approaches infinity, so x is not dependent on it. So I'm gonna go ahead and pull this out from my limit, and that's gonna give me sine of x, and now we have the limit as n approaches infinity, and what we're gonna have is 2 to the negative n over sine of x 2 to the negative n. Now I know this looks a little different, but trust me, it's the same thing. Why? Because we have 2 to the negative or 2 to the n on the bottom, so I brought it to the top. So now, let's talk about what happens when you plug in infinity. We have 2 to the negative infinity, which is actually gonna be 0, and then we have sine of x times 2 to the negative infinity, which is also 0. So we have 0 over 0. So we can go ahead and use L'Hopital's rule. And now, as we use L'Hopital's rule, we have the limit as n approaches infinity. Oh, I really hope this is gonna fit. Now we gotta take the derivative of this, which is gonna be negative 2 to the negative n natural log of 2 over, and now we're gonna take the derivative of this, which is cosine of x 2 to the negative n times the derivative of what's inside. Now, x is not dependent on n, so we have x, and then we have negative 2 to the negative n natural log of 2. I just got that to fit. But look, on the top and bottom, those go away. So really we're just left with 1 over cosine x to the negative n times x. So we go ahead and plug in infinity again. This leaves us with 2 to the negative n on the inside, which is 0. So cosine of 0, that's just 1. So we have 1 times x on the bottom. So we have sine of x times 1 over x, and that's just gonna be sine of x over x, and that's what the infinite product is. Because now we can go ahead and say this entire value is just sine of x over x. So we can go ahead and finish this off and say we have the integral from 0 to pi over 4 of x times the value that we had right here, sine of x over x with some disrespect to x. Look at that, the x's go away, and that leaves us with an integral from 0 to pi over 4 of sine of x dx. And now we just integrate. This is gonna be negative cosine of x, but we're implementing the first fundamental theorem of calculus, so we have to make sure that we have 0 to pi over 4. Let's go ahead and plug in the pi over 4 over here. That leaves us with negative root 2 over 2 minus negative cosine of 0, which is gonna be plus 1. So really our solution is 1 minus root 2 over 2. Let's get some common denominators on here. 2 minus root 2 over 2. And guys, we officially have done an integral that has an infinite product and is actually very satisfying. I hope you had some fun. This was Mathmas Day 10.